All right, now we are going to do an example where we find a probability with a problem that comes from a sampling distribution of a sample proportion. So the example says that the Texas Workforce Commission reported that the state unemployment rate in March 2007 was 4.3%. Find the probability that a sample of 250 people will have an unemployment rate of less than 3%. So looking here, the unemployment rate in March 2007 was 4.3%. A sample of 250 people, we're finding a probability less than 3%. So let's see, I have a few numbers that I'm going to write down. 4.3%, which is 0.043. 250, which I know is going to be my sample size. And then 3%, which is 0.03. So this 3% is the unemployment rate for the sample of 250 people. So that would be the sample proportion, which is the P with the little hat on top of it. And then the 4.3% is the unemployment rate for all of Texas. Why are there so many little dots on my page? There we go. So then that's P. So these are the three values that you will need to identify when you have a sample proportion problem. And one of the ways to tell the difference between a sampling proportion sampling distribution and a sample mean sampling distribution is percentages versus means and standard deviations. So now I need to make sure that I have a normal distribution. Oops, this is not officially a step. Is it normal? So we're going to use the central limit theorem to answer that question, which for proportions, the central limit theorem says that n times p times 1 minus p must be greater than or equal to 5. So n is 250, p is 0.043, 1 minus p, 1 minus 0.043, 10.3, which is in fact greater than 5. So I have a normal distribution, which makes me happy. So that means that I can use the 4-step process for finding a probability, because that's what this problem is asking me to do. Find a probability. I have a normal distribution. So I'm going to go into that 4-step process. And in step one, I'm going to use the z-score equation for a proportion, which is p hat minus p divided by the square root of p times 1 minus p divided by n. So our p hat is 0.03, p is 0.043 divided by 0.043 times 1 minus 0.043 over 250. This is how we find the z-score. So I just happen to have the answer for the bottom, so I'm going to go ahead and write that out first. Now on the bottom here, it's a really long decimal, and I want to keep all of those decimals that I see. So this is all that I was given. So I'm going to write all of those out. And then up top, I have negative 0.013. And then I divide that by 0.012829809, and I get negative 1.0133. As I've said, I'm used to giving 4 decimals, so that's why I do it. So that's step 1. Now I have a z-score. This z-score is treated the same as any other z-score. It's telling me how far away from the mean I am in terms of the standard deviation. So I'm a little over 1 standard deviation away from the mean. So step 2, I draw my curve just like I would if I was looking at an individual from the population or if I was looking at a sample mean. Negative 1 is about maybe here. And we want the probability that the unemployment rate will be less than 3%. So step 3 is to shade the area that we want to find on our curve. So we want to find the area less than negative 1.0133. And then we're going to find this area, which is interpreted as a probability. Using Excel. So equals norm.s.dist. Type in the z-score followed by true. Negative 1.0133. And we get a probability of 0.1555 when we round that. We don't have to use the complement rule because we wanted the area to the left, and that's what Excel gives us with norm.s.dist, is the area to the left. So here you go. Here is how you find a probability using a sample proportion from a sampling distribution of the sample proportion.